Okay, let's get into it. Our mission today is a deep dive on the NTI E-5DB-D. We want to figure out what makes this little box so essential for protecting your digital world from, the physical one.
Right, and I think the key thing to grasp is that it's fundamentally a preemptive defense layer. It's your frontline guard against all the physical things you worry about: temperature, humidity, water, power issues, you name it.
The things that software just can't see.
Exactly. It's watching for what humans and code usually miss.
And it seems pretty flexible right out of the box. It has the internal temperature and humidity sensors, but then it gets interesting.
That's where the expansion comes in. It supports 5 external sensors you can configure, plus 5 more digital inputs.
And those are sensitive to contact closure, which, for anyone who's not an electrical expert, is basically just a simple open or closed circuit.
Perfect way to put it. Think a door switch, a smoke alarm contact, any basic on-off alert you can imagine.
Which really builds into this whole alert ecosystem it has.
It's a huge part of it. When a sensor goes out of range, it can notify you in, well, pretty much every way possible.
Okay, like what are we talking about here?
We're talking email to up to 17 different addresses, and then you have LEDs, an alarm beacon, a siren, SNMP traps, of course.
17 addresses. That seems like a lot. Doesn't that risk just a flood of notifications, alert fatigue?
It could, but that's where the intelligence comes in. You can actually set up 50 different events, and then you can combine them into 20 smart alerts.
So it's not just it's hot, it's more like...
Exactly. The temperature is high, and the main UPS is now on battery. It adds context.
That moves it beyond just screaming for help and into actually doing something.
Right, because when an event fires, the unit can send SSH commands to say, soft shut down your servers. It's digital damage control.
And it's not just software control. I saw it has 2 output relays.
It does, and they're potential free switch contacts, which is a technical way of saying they're just clean, isolated on-off switches.
So you can safely hook them up to pretty much any external device.
Precisely. The system can then trigger, I don't know, extra cooling fans or cycle the power on a network switch that's locked up, all on its own.
Okay, but all of this relies on the monitoring unit itself surviving whatever's happening. So how reliable is this thing?
That's a critical point. It's built for reliability, starting with dual redundant power supplies.
So if primary power goes out, it just flips to the second one.
Instantly. It switches to the second source before it even thinks about touching the optional internal battery. That kind of engineering gives it a mean time between failures of 170,344 hours.
Wow. That's what, almost 19 and a half years?
Yeah. It's built to outlast the gear it's protecting by decades.
And what's running all this? What's the brain inside?
It's actually running Linux, which is why it integrates so well with open source tools like Nagios or MRTG. It also acts as a network watchdog itself. It can ping up to 64 devices on your network.
And if one stops responding, it sends an alert.
Immediately.
So for a bigger setup, you can scale this up.
You can. You can cascade up to 4 other units as slaves under one master, and you manage them all from a single web page.
And what about securing that access?
It's all locked down. You've got HTTPS, SSH v2, AES, 256-bit encryption, and LDAP v3 support, which is huge for enterprise.
So it integrates with your company's user directory.
Yes, so only authorized people can even get in. And one last thing to bring it all together is the IP camera support.
Oh, interesting. So you can see what's happening.
You can. You get the single view with a live camera feed right next to your environmental data. And the best part is, any event, a door opening, a temperature spike, can trigger the camera to take a snapshot.
So you get instant visual proof, context for the alarm.
That's it.
Okay, so we've been talking about standard server rooms, but I saw there are industrial models that can operate from -40 all the way up to 185 degrees Fahrenheit. So that leaves me with a final thought for you to chew on. What kind of data center or remote facility operates in conditions that harsh? Think a communications hut on a pipeline in the Arctic, or maybe an edge computing node in a desert. What kind of unique protection do they really need?